Furstenberg, a Google Developer Expert, GDE, and who will explore the intriguing relationship between LLMs and bridging the human-computer interactions. So welcome, Alan.
Hey there. Thank you. It is great to be here. I always love talking to these groups. And it's always wonderful to reach out and be able to talk about this stuff. And it was great to see Peter. It's going to be a tough act to follow. So as you said, I'm going to be talking about using large language models to bridge the what I like to call the fuzzy human digital computer boundary. But more importantly, and I think the message that I hope everyone takes away from this, if my presentation suddenly stops, my connection crashes right now, what I hope everyone takes away from this is that the LLM tools that we have today enable every developer, no matter what your skill level of machine learning is, from a total novice to an expert, no matter what programming language you are using, you have the tools now to be able to do some amazing things that we were never able to do before. My name's Alan Furstenberg. I'm a software developer and consultant. I work for a small consulting company located in New York. But I'm also a Google Developer Expert and a Google Cloud Champion Innovator. And basically what that means is that I don't work for Google, but I work pretty closely with Google's developer relations teams and engineers to help them understand what we as developers need to use Google tools better, faster, more efficiently, and so forth. Also, what I do is help us as developers, the entire developer community, understand what Google tools are bringing to us, how we can use them, what they are good for, and how they take us to the next level. And as part of that, I'm contributing to an open source project called LineChain JS, or LineChain JavaScript. You may have heard of LineChain. It started as a Python project that helped enable Python developers get access to a wide range of these new LLMs that were coming out. The JavaScript and TypeScript version is more or less the same vein. A lot of my contributions have been, how do we get these libraries that are codifying certain patterns that we're seeing more and more in using large language models? How do we use them with the tools that Google is providing? I'm the co-host of a podcast called Two Voice Devs, originally started about 3 years ago to talk about voice in the programming arena and how programmers can use audio. And increasingly, we're doing more and more with AI and machine learning. And I run weekly office hours as well. Here's some basic info on where you can find me. Spiders.com is the company that I work for. Prisoner.com is my personal page. It's easy to find me on Twitter, Blue Sky, and on LinkedIn. So what's the fundamental problem here? Fundamentally, it kind of boils down to humans are analog creatures. We think of things in fuzzy terms. We have broad scoping ideas of when we think of things. But computers don't work that way. They're digital, they're discrete, they're concrete. Everything in a computer fundamentally boils down to a 1 or a 0. And everything is built up off of that. As you can kind of imagine, the two of them don't mix terribly well. So traditionally, what we've had to do is we've had to think digitally in order to work with computers. We've developed programming languages that boil things down into discrete digital chunks. We've built databases that store discrete and finite values. We've taught people how to ask computers questions using the discrete language that they are good at, and we've built new ones. But LLMs kind of turn that around. LLMs can understand, and I put that very carefully in quotes here because I know the significance, but LLMs understand us by taking our fuzzy notions, by taking the things that we are vaguely expressing and turning those into the discrete sets that it knows how to deal with, that turns it into values that it knows what they are and what they mean and how to work with them, that turn them into numbers that it can compute how close things are. That gives us an incredibly powerful tool that for the first time, we no longer have to teach people how to do something. we've taught a computer how to learn from us and learn what we want. But it's important here to understand what LLMs are and what they are not. Coming up in a little bit, good friend of mine, Noble Ackerson, has a quote that he's used that I absolutely love, and that's to remember that large language models are not a source of truth. They're not search engines. They're not good at being search engines. But what they are is a way to transform one thing into another. So they're good at doing things like turning phrases into code fragments, turning phrases into search terms, turning phrases into numbers. And then on the other side, doing that transformation in reverse, taking the results of a query and turning that into a textual result that can be spoken to us, or that a human would find it pleasurable to read, rather than trying to, look at a bunch of brackets that may not mean anything. When we take that and combine it with the APIs that we as developers already know and are familiar with, then our applications can do amazing things. This is a powerful new tool that all developers are able to tap into. So how do we do that? Kind of breaks down into 4 parts. We're going to first get a request from the user in some fashion. We're going to use the LLM to turn this request into a discrete representation, into those numbers. We're based on those discrete results from the LLM, we're going to transform it into other discrete results. We're again going to end up with more concrete information that the computer is familiar with. But then we're going to use the LLM to take those results, turn it into response to the user, send it back to the user, and repeat the process. So what does that look like? So here's one example. User types something into a chatbot. We're very familiar with this notion these days. The LLM will take this information plus other context that they already have. Maybe they're going to be taking into account the time of day or the day of week, or the fact that the user likes to use bicycles instead of cars. And they're going to turn it into, say, a function call and describe what those parameters are. It's not going to make the function call, but we've given it a list, for example, of known functions and what those parameters are in each function. And maybe we're going to it's going to give us back what that function call is and what the values of the parameters are. We're then going to, after some sanity checking, execute that function with those parameters. And like any good function call that we've built, it's going to be returning back into a nice standard format, an object format or a JSON format of some sort. We're then going to take that JSON notation, again, a standard notation, feed it into the LLM, but also feed into it the original request as some additional context, and give it a prompt to say, turn this into a chatbot response. We get that response, we send it back to the user may ask another question, and we keep going. What's another example? Okay, so what if the user is going to be talking to a voice assistant? The LLM will take what they've said, what their spoken text is, turn that into what's known as an embedding, or a vector of floating point numbers that kind of represents what it is that the user has just said. It'll then use those embeddings to locate in a vector database other documents that are nearby that request. And these are, as Peter kind of alluded to, these may be things that are similar to what the request is, or may address it in some way. So it gets back a bunch of documents that may answer the question. Now, given those documents and given the original request, it may send all of that to an LLM and say, summarize this, and summarize it using SSML, which we can then speak back to the user. And again, we repeat. Another example, what if the user asks a question about data that they're searching for, that they want to summarize? Maybe it's in a spreadsheet, maybe it's in a database, who knows? The LLM can take the question and the schema from our database, for example, and we've prompted it to create an SQL query. Again, after doing some sanity checking to make sure the SQL looks sane, we're going to execute that on our database using API calls that we know and we're very familiar with, get the results from the database, and again, feed those results along with the initial question back to the LLM to summarize, respond with that summary, back to the user, and repeat the question. But what tools, what skills do we need in order to do all of this? The most important thing, and again, I cannot emphasize this enough, we have our basic skills already. As developers, we understand APIs and libraries that we're familiar with. As developers in a particular domain, we may understand our business logic or the problem domain. All of that are the most important things that we need to fundamentally bring this up. We'll need to know some additional things, of course. For example, we need to know how to do LLM prompting. And that's a whole host of conversations that are out there about learning how to do prompting, how to fine-tune our prompting so that we're asking the question in just the right way. But fortunately, there are tools out there that are helping us. Tools such as MakerSuite from Google, which gives us an environment where we can build in prompts and fill in parameters and fields for those prompts, or the Vertex AI Model Garden, or Generative AI Studio. All of these are tools that help us build our prompts and get familiar with how to write a prompt. And then we need an API or libraries or something that gives us access to the large language model itself and lets us streamline asking those questions, getting those responses. And here's where something like LineChain and LineChain.js can really help us out, because it helps put all of that together and lets us just get on with asking the question without having to deal with too many details about how to make those calls. If we look quickly at, kind of the middle question there, taking prompts and applying parameters to it. Prompts, and again, this is a whole subject that we really could spend hours on. But generally, what you want to do when you're building your prompt are set up things such as giving it a role description. Help it kind of frame the question in terms of what kind of expertise you're asking for. Give it operational context, what the schema is, for example. Maybe user-specific context. They like to ride a bicycle. In a lot of cases, we can give it examples. And this really, again, helps set it up for what the structure is going to be that we are expecting the LLM to return. We want to give it task descriptions. And then most important, we want to give it other user inputs. And then finally, what's the ask? What do we want it to give back to us, given all of this other information contained in the prompt? Beyond the prompts, however, we've also got parameters. And these are things that let us kind of tweak how we expect the prompt to behave. So at the very basics, what model are we going to be using? What temperature or how much randomness do we want to introduce in the question and answer? For things that we want very solidly grounded, like code that comes back, we don't want much randomness at all. Whereas for the more flexible human-sounding answers, we want a little bit of randomness so it doesn't sound as robotic. We'll also want number of tokens that are returned, some safety filters, or particularly if we're dealing with things that are skirting the edge of medical information, we don't want it to return too much medical information because that could be dangerous and somewhat out of our control. There are also other esoteric parameters that you start getting into when you're playing with these models, things like top P and top K. Most of them have to do with randomness. In general, most people don't worry too much about them. As I said earlier, there are tools like MakerSuite, which are available from Google and available for most everybody in North America today. Most everybody in the United States anyway. Sorry, Canada. What this lets you do is manually enter prompt information, save it, and adjust the parameters. One of the other neat things about MakerSuite that I really haven't seen too many other places is you can kind of treat it as a templating system so that you can do things like say, here's where I'm going to want to fill in a value, but use the rest of it as a boilerplate, and then go in and try out some things. Most importantly, however, I want to emphasize, keep experimenting. Prompt development and design is still more an art than a science. So the more you play with it, the more you fiddle with it, the better your chances are of getting good prompts. And then there's LineChain. As I kind of alluded to, LineChain helps streamline a lot of the processes and helps introduce patterns that are well accepted and understood in the LLM community these days. So at the very basic of it, it gives us tools like building prompts, taking templates to fill in values that may come from the user, applying it to a wide range of models. So for example, you may want to try something on text, chat, or an embedding model that's currently available, or you may want to try it on the next version of something that's available and try things out and see how they work. Or as you're moving towards an enterprise system, you may want to move from the Maker Suite set of tools into something working on Google Cloud like Vertex AI, both of them using the PaLM API or the PaLM model under the hood. It also likes working with things that it calls documents. And this allows for atomic component of data. So basically taking web pages, PDF documents, and so forth, and breaking them down into smaller chunks that the AI may be able to better work with. Especially when we're dealing with things like conversational AI, where there's a back and forth, we also need something that's known as memory to store those historic conversations, to store the context that the user is giving us so far. Then we start moving to more advanced things. How do we group these things together? So for example, we will want to build a prompt and collect information from the user and apply it to that prompt, and then take that prompt, feed it into a model to get a result, do some processing, and then feed it into a different model. Things like chains and agents let us stream those together, and there are some fairly standard components that have increasingly been growing, so you don't need to write much of the code at all. You're letting the library do a lot of that processing for you. Okay, I already hear you. We're 15 minutes or so into this. I haven't seen a line of code yet. Show me the code. So let's go back and look at the example. This would be the third example that we talked about before, where the user is going to ask a question about data to search for or summarize. We're going to have our LLM take the question and the database schema information and create an SQL query about it. We're then going to evaluate that query using standard tools that we already know, get the results from the database, and then once we have those results from the database, send both the original prompt and those results to an LLM to summarize and respond. So what is that going to look like? And what I've set up here is a database that has two tables. It's kind of mimicking the notion of a user bulletin board system. So we've got a table of users and when they last logged in, and we've got a table that consists of everyone's posts and who posted it and when they posted it. So the first thing we're going to see about our code is that it almost completely mirrors at the highest level what our data, or what our flowchart earlier just looked like. We're going to get the request. We're going to turn that request into SQL. We're going to run that SQL. And then based on both the original request and the values that we got back from the SQL, we're going to get a response. We're going to show the response, and we're going to keep doing that. So let's see what each of those four functions look like. Now, the first of which is really, and I'm using JavaScript for my example, but again, I want to emphasize, you can do this in any language. All these are illustrating, and what that flowchart illustrates is whatever language you have, you'll have the same kind of pattern. So to get the request, we're going to use the readline library that's part of Node.js. Prompt for the request, get the value, return the value. Simple, straightforward, uninteresting. But it's building on the knowledge that we already have. Let's get some more interesting stuff. Okay, so how do we turn that request into SQL? And although there's a bit of setup here, fundamentally, what we're doing is just two lines. So in the setup, we're going to build a query model. And in this case, I'm going to be using the Google PaLM model, which is available through MakerSuite. And I'm going to set the temperature on that fairly low, because what I want to do is I want to turn what the user has said into an SQL command, and I don't want it making stuff up. We're also going to need to set up some things like the prompt string, and we'll look at the prompt string on the next screen, and build that into what they call a template. What the template does, and this is a LineChain notion, is that it's going to take a value or take a set of values, in this case it's going to be the request, and put that into this boilerplate that we've built. Then finally, we're going to utilize something called an LLM chain. And what the chain is basically, what this LLM chain is, a very simple, straightforward chain that says basically, given the template boilerplate and certain values, apply that to create a prompt, send the prompt to the LLM, get a response. So we've set all of that up so that all we need to do when we call the function with the request is that we call the chain with that request value and we get a result. And that's it. All of the hard work has been done for us. We're basically just configuring a bunch of stuff. Now, the big notion in here, what we needed to configure is, what does that prompt look like? And in this case, it's a fairly extensive set of prompts. But you'll notice most of that is just that we're defining what the two tables look like. We're defining what our users look like, a full name, when they last logged in, and we're defining what their posts are. An identifier for the post, the user, what category it might be in. Maybe we've got some rating, we've got a date for that. So this is all some information about the post itself. And then we're telling it basically, we're kind of giving the instructions then to the LLM, kind of leading it on. It's a database expert. It knows what databases are. Okay, here's what a schema looks like. The user is going to request something, and you should give an SQL query text. And you should just give the SQL query. We don't want explanation, but here's what it's going to need to do. Always use fully qualified names of tables, bunches of other stuff here. Here's where the request is going to be put in, and we're prompting for the query. Here is our ask. That's going to be what goes into the prompt to hopefully turn that into SQL. So now from this, we have some SQL. What do we do with it? Well, for those of us that know SQL, what do we normally do with it? We need to send it as a query somewhere. One of the things I point out, though, and I have this in a fix me here to remind us, is that we should sanity check what the SQL is. We don't want it doing things like deleting database, inserting stuff into the database. So there are some basic checks that we can do to make sure that this is just going to be a select and that it doesn't have any odd characters that are trying to escape our sandbox. But then you have to remember, these are things that we've known how to do for a while. SQL injection's pretty well understood and SQL cleaning's pretty well understood. So hopefully we can apply those skills that we have to this. And then we make a database call, which we know how to do. And we get the results back and we return those results. Okay, so now we've got a bunch of results. What do we do with it? And again, this code looks very, very similar to the earlier one where we're sending the request off to the LLM. Again, we're going to be using the Google Palm model from MakerSuite. But you notice in this case, we've changed the temperature. In this case, we want a more friendly response rather than a robotic sounding response. So we're going to give it a little more leeway and randomness. We're again going to use a different prompt string. And one thing to note, and again, we're building a chain, we're building up the template from it. But one thing to note when we make the call, that we need to pass it two pieces of information. We're going to be passing it the request, what the person initially asked for, and we're going to be passing a JSON representation of the values itself. But otherwise, this looks very, very similar to the previous code that we had. Our prompt here, however, is much, much simpler. We're basically saying, you're a data analyst. You've been given the question that was listed below, and after doing the research, here are the results that you found. Now, what I want you to do is provide a solution as if it was being read out over the phone. And that kind of prompt, as if it was being read out over the phone, is kind of more to urge it into a way that sounds user-friendly. It's not providing too much information. It's not providing it in weird date formats. It's meant to sound like a human is going to be listening to it. And then we're going to fill in that boilerplate with two pieces of information: the question that the user initially asked and the data that we just got from our database query, and then give it that lead. Give me the answer now. Okay, so what does this look like? So here's an actual run from the code. I'm actually using code that has a couple more comments in it that tell us what's going on at each step. So when the user asks, how many users do we have? We see that it turns it into an SQL prompt, basically selecting how many rows there are in users. If we had something about, how if a user was active or inactive, it might add the flag to check that as well. The result it gives back is pretty straightforward. It's not a complex set of rows here. Basically the number 5. we pass that question, that answer to our second LLM, and it gives us, according to our records, we have 5 users. Human sounding, easy to understand and digest. What about us asking when John Doe last logged in? Well, it knows that John Doe seems to sound like a full name, so it's going to be setting up a query against the full name, and it's going to be getting the last login field from this. The result that it gets back is, again, a fairly straightforward data structure, although it indicates it's a BigQuery timestamp that has a value in it. But all that it returns to, that has a full date and time, but all that it returns to us is the date. So again, we can see from this how it has taken a very human question, turned a very human and very fuzzy question in some ways. You'll note that some of the fields, some of the questions, for example, when I say, when did it last log in, doesn't always in every case match the fields that I'm looking for. It's taken our fuzzy question, turned it into a discrete thing, an SQL query, executed that SQL query, turned that into a discrete answer, and then turned that discrete answer back into a human fuzzy set of text. So I have a little bit of time, although not too much, to take some questions. If you want to learn more, here are a few URLs for you to take a look at. For more about POM2 in general, there's a link. To learn more about the Makerspace set of tools and API, makerspace.google.com, and to learn more about LineChain.js, there's the GitHub repository. I look forward to seeing what you can do, because again, I want to emphasize, I cannot emphasize this enough, you can do this. These tools are at your command. Thank you very much. It's been great to speak with all of you, and I look forward to seeing what questions you have and what you do with all of this, these features that are now at your fingertips. So the first question we got, is it possible to force the LLM output to be deterministic so that the LLM answer can be safely forwarded to downstream program APIs? The answer is yes and no. We can certainly get it to be more deterministic. And by deterministic in this case, though, we mean that it's more repeatable. So given the exact same input, we'll get the exact same output. Whether that output is exactly what we want is tougher. The first thing to do is lower the temperature as low as you reasonably can. A temperature of 0, 0.1, 0.2. I tend to like 0.2 because it tends to pull things out a little bit more accurately. But it's something you need to play around with. I think the underlying question here, though, is how do we make sure that what we've got from the LLM can be sent to the API? And the best answer here is check it. You know, what we're getting should be a fairly well-known and understood data structure. And from here, we can now use tools that we already have to do sanity checking. We should make sure that the data structure meets a data structure that we want, that it has fields that we expect, that it isn't malformatted in some way. But we've got lots of tools that are not AI tools and are therefore much, much easier and cheaper to run to do those sorts of things. Two other things to keep in mind that may help in some ways on this. One is that when you're building a prompt, give it examples. Remember, these LLMs are pattern systems. So if you give it examples of patterns that you're expecting to get back, it'll try to follow those patterns. That's kind of how it's built to do. The second is, and these are starting to get to be more advanced concepts, that we're now seeing LLMs that are checking the results of other LLMs. So you will, in an SQL query, for example, you may send it a query, and it doesn't need to know anything about the structure, but you may send it, here is a query that we're about to execute. What are the safety concerns here? Or rank this in terms of safety from 1 to 10. And for something that's a 10, you reject it. And for something that's lower, maybe you handle it in other ways. So those are, a lot of techniques, but there's also a lot of conversation, a lot of innovation that's going on with all of these sorts of things. This is a fantastic question. I don't know where to start. That's hard because you're seeing a lot going on out there with LLMs these days. Everyone is talking about it. I would start by looking at Google's Maker Suite, which is just a playground where you can start building prompts and experimenting with it and seeing where they come, where they go. This also is a great opportunity for me to give a plug for your local Google developer group. And part of the reason is because there you're going to find a community where lots and lots of other people have the exact same question that you have. Where do I start? I hear a lot about LLMs. What do I do? What are they? How do I use them? Again, they're also going to talk about how do you build one? How do you train one? How do you do fancy things with them? But fundamentally, these are the communities that can be out there and helping you understand, how do you get started? What's that first step? Where do you, I saw this code. Where do I go with it? I'd also, if you're familiar with Python or you're familiar with JavaScript, turn to the LineChain communities, because the LineChain communities are doing some incredible work out there to help people understand how to use these LLMs in your code. Again, bring your base knowledge and then up it with what these LLMs can do.